So good evening.
Good evening, Father Brinkman.
Leave it to the guys to give you support. I'd like to welcome to our Redemptorist community Dmitry Kousnetsov, who is one of the foremost shroud experts in the world right now, but he asked me not to say anything about his work. So I won't steal a second of his thunder on that, just to welcome him here among us. And what he asked me to do was just to give a little background as to what the Holy Shroud is. And what I thought I would do is just give a little history of it, where we think it's been, the years that it's been in existence. So, of course, at the present moment, it is enshrined in the Savoy Chapel in Turin, part of the Archduchy of Savoy in northern Italy. And the ownership of the Holy Shroud is divided between the Cardinal Archbishop of Turin, the House of Savoy, and the Vatican. And in 2 years, there's going to be a very important anniversary of the Holy Shroud. In 1898 was the first photograph taken by Pio II. And they were simply wrapping it up and wanted a couple photographs of the Holy Shroud taken. And when he took the pictures, remarkably, an image appeared that looked something like this. The Holy Shroud, naturally speaking, looks like this, with a light background, with a very faint image, a very faint shadow-like image. And this is more high relief than you would actually see if you saw the shroud. It's very delicate. It's dark, slightly darker brown on brown. And when he developed the face area, it came out looking like a positive. So what they thought they had for many, many years is something like a photographic negative that no one could ever explain. It's just when the negative was developed, it looked so striking that they immediately interpreted this as a photographic negative, and what they were looking at was the negative image. And it's certainly true when you look at the whole shroud in the negative, which it does look like a positive image, very faint, of course, but a positive image. It was in this Chapel of Savoy since the early 16th century, since the early 1500s. Before that, it was somewhere in southern France. And the places changed between Livray and the areas, suburban areas around Nice, France. And it belonged to a Crusader family named Geoffrey de Charnay. And there were two Geoffrey de Charnay. They distinguished them as Geoffrey de Charnay and Geoffrey de Charny. The one was a Crusader, and when he got back from the Crusades, along with many of the Crusaders, they burned them at the stake for idolatry. This would have been in the 1200s. A couple generations later, a Geoffrey de Charny emerged. They have no historical records there's any connection between the two families, but the similarities in the names are striking. And Geoffrey de Charny is the first owner of the Holy Shroud in the West. He started displaying it in the chapel that he had in his aristocratic royal family. And in fact, the bishop complained that he was displaying an idolatrous image, and Pope Clement VII, I think it was, wrote to Geoffrey and told him not to display this idolatrous image without having seen it. Before that, what they think happened to it was that it was kept in Constantinople and that it was seized by the Crusaders and brought to the West. It had been in Constantinople since around 600, 700, 800. The history is very indefinite. Before it was in Constantinople, they think it was in a little town in Asia Minor named Odessa, which, if you looked at the map of Israel, Odessa would be way up here where Turkey would be, in southern Turkey. And it went there within a generation or two after the death of Christ starting in Jerusalem. They think it was taken from Jerusalem to Odessa to this king Abskar, who was a Turkish king who became a Christian early on. They have some records of him around 200 AD. And they think that he was the first one to enshrine the Holy Shroud. And of course, they didn't want to display the whole thing. Of course, you see an image of a naked person. They had reverence for the the body of Christ in such a way that they thought it would be improper to display the whole thing. So they had it wrapped up in such a way that all you would see is the face. So there are evidence of folds on the Holy Shroud that would indicate the way it was kept through history, folded up, and just the head being displayed, and that would be kept in a case, and the face displayed in an oval manner. So one of the interpretations of the Holy Shroud is that it has always reflected the history of the Church. During the theological controversies of the early centuries, the Church Fathers, they disguised the body of Christ and just had the divinity, you might say, displayed in the face. As the scientific community became more active in the Enlightenment, the Renaissance, more of the shroud got exposed. During the Reformation, the church was torn apart, and it was in 1531 that there was a terrible fire where the shroud was being kept, and that's where some of these patches, you'll see these patches that are on the shroud, they were sewn by the Sisters of Charity around 1535 to disguise or to support the material that was burned away. When the silver reliquary melted, of course it was folded in such a way that one corner was burned that went through the whole cloth, so that you had these little patches that were sewn on to keep the material together. And there are other markings on the shroud. Of course, there's watermarks, like here, down here, where they tried to put out the fire, where there would be damage from water. There's also other fire damages, like in these little holes in the cloth right here. You don't see the holes in the cloth because there's a backing to the shroud. There's a piece of cloth behind the thing that always keeps it supported. And during some of the testing, they would look underneath of the shroud to see what was under there. So I don't want to say too much about all of this because Dimitri will enlighten us on many of these things. But this is the cloth that we believe has traveled through history. In the carbon-14 testing, what they seemed to prove was that it was a medieval forgery, prove in quotes, because they found a lot of paint on the shroud. So they did find pigments on the shroud, and they think those that support the existence of the shroud as a relic of Christ would say that paint got on there from the medieval times when they would have the custom of making third-class relics. So someone would paint a representation of the Holy Shroud. Then sometimes while it was still wet, they would touch it to the actual shroud to make it a third-class relic. And so that's how they think some of the pigments that they find on it got there. But on the image itself, you find no brush strokes. The depth of the image area is less than the thickness of a human hair. They've held the shroud up to light, shine light through it, and the image area just goes away. It's so thin, this image area. It resembles a scorch. It resembles some sort of celluloid oxidation that happened very quickly, very fast. There's some very remarkable things about the image that just can't be explained or can't be duplicated by modern science. So, since I said the words modern science, I'll give you Dimitri and let him take it from there.
Thank you, Father Brinkman. It's a great pleasure to be here. If you have any problems with my English, please feel free to interrupt me, ask him questions. But I will try to be as understandable as I can. First of all, following Father Brinkman's explanations, I would like to note that in the tradition of Eastern Church, in the Russian Orthodox, Bulgarian, Serbian, Greek, Coptic Orthodox churches, in liturgical tradition, there is a very special element, and this element is a shroud. For example, in certain kinds of cases, the Russian Orthodox priests celebrate the Eucharist on a table covered by the cloth with the image of Christ on it. And moreover, in the liturgical tradition, that particular piece of cloth is called officially as a shroud. So, plus if you would try to investigate some peculiarities of Asian icons, especially those icons which were created in 4th, 5th and 6th centuries in Byzantine Empire, in island of Cyprus and in certain Egyptian areas, you will probably find a great similarity or homology between the face image of the man of the shroud and those icons. And this similarity is very, very impressive. And not even being an expert in iconography, my specialty is chemistry, I'd just like to mention that intriguing fact. And because of very well-known political events which allowed us to travel, to exchange ideas and stuff like that, now I guess is a good time to exchange cultural traditions and some sort of historical information from both East and West in terms of the Shroud of Turin to complete the whole picture we have by now about the Shroud. Now, before 1991, I had no even a chance to hear or to read something about the Shroud of Turin. Even now, in 1995, there is no one single book on the Shroud of Turin in the Russian language so far. And certainly, a couple of years ago, the situation with availability of any information about the Shroud for Russian public were much worse than we have now. My specialty is biopolymer chemistry, and I used to work for a long time for forensic chemical institution in Russia, and even now I'm working in a lab for some forensic purposes. I'm a head of a small private laboratory which has a lot of orders from Moscow Police Department in particular for some kinds of chemical analysis. But starting with 1990, we have been involved in a certain kind of archaeological chemistry analysis as well. And at the end of 1991, I attended a small conference in London, England, on the radiochemical or radiocarbon dating method. And my report has been devoted specifically or particularly to accuracy, to efficiency and accuracy of the radiocarbon dating in archaeology. On that time we had enough reasons for skepticism about the accuracy of radiocarbon method in general. Radiocarbon method is a very good method. In fact, we still do not have better for archaeological purposes. But as well as any other scientific method, radiocarbon method is not ideal, is not panacea, and this method obviously has limitations. And you could expect correct conclusions from this method only in case if you would be able to take into account those limitations, of course. So we delivered a report about radiocarbon method expressing our skepticism. We collected many references from world available literature, published in many languages, including English, of course, first of all, from which we accepted that kind of skepticism. And basically, a radiocarbon method provides probability, but not certainty. And now let me tell you how most archaeologists work with radiocarbon method before 1988 and after 1988. First, they dated the object historically and stylistically, taking into account a complex historical context of the particular site, like historical records, like stone graves, signatures, like some cultural levels and strata in that site, stuff like this. And finally, they, archaeologists, coming to a conclusion about how old is this particular object. And then, to be precise, to make sure to clarify the conclusion, they ordered radiocarbon result. Then, if then a radiocarbon result fits the whole stuff of evidences that they had before, they remain it. If not, they reject it. Before and after 1988, the most prominent archaeologists in the world, and first of all Israeli ones, used and still using radiocarbon method as additional method for clarification of those conclusions they already had by analysis of historical and statistical details. Which amazed me a lot is a very famous publication in Canadian Journal of Forensic Chemistry published in 1968. And the first radiocarbon approach has been introduced to the scientific community in the mid-50s. So some people collected shells, living shells, mollusks from Atlantic Ocean, living ones. Then they homogenized the shell into the powder material and then sent it to Rochester, New York, for radiocarbon facility with a question, how old is this object? And the radiocarbon facility gave an answer that it is 2,000 years old, but it's still alive. So that's actually not too funny, it's a problem of accuracy and probability. But that kind of errors happens from time to time. And the radiocarbon method applied to the Shroud of Turin is really, even superficially looking, far from ideal. First of all, the piece of cloth which has been separated from the shroud for that particular analysis has been chosen in one particular place, not in different places. And that place is very close, located nearby the burned site, which has been damaged during the fire and carbonized perhaps. Then there are some suspicions that those labs which were on charge of radiocarbon dating knew in advance what the sample is all about, that they knew that it was a shroud. There are some indirect evidence that in reality this experiment was not blind. And like as Father Brinkman said, the appearance of the Shroud of Turin in the Western Europe has been dated to a mid-13th century or 14th century, depends on historical evidences. So in 1988, a large international team of experts in radiocarbon dating and museum science and from 3 laboratories from Zurich, Switzerland, Oxford, UK, and Tucson, Arizona, published their report in a worldwide circulated magazine, Nature, with the conclusion that this is a Middle Ages forgery. They dated this relic to 14th century. And like they said, with a 95% confidence. Now, I am not an expert in the radiocarbon dating. And I'm not an expert in the Shroud of Turin either. I'm a chemist. And I do some archaeological work in my lab with physicists and computer scientists. And those radiocarbon dating itself, we ordered. We did many things ourselves, but as for radiocarbon analysis, we ordered that analysis in Arizona, here, and in Protvino in Russia. And when I said we, I mean we contacted Arizona lab through a participation of our friend from Italy, Mario Maroni, perhaps you know. So in 1991, soon after my report about the skepticism on the accuracy of radiocarbon dating in archaeology, I've been approached by a gentleman from France whose name is Guy de Bertot. This is a member of CIELT, French group specifically designed, almost like Hollow Shroud Guild here in America, for purpose to collect and analyze any information, scientific information concerning the Shroud of Turin. Monsieur Bertot did express his interest in our studies. We invited him to come to see us in Moscow. He came. And since then he visited our lab at least 11 times in the recent 3.5 years. He gave us money and order for first step of our studies. He gave us a simple question, simple for him, not for us. And the question was, is it possible or not to prove experimentally in the laboratory a probability of a change of radiocarbon content in the linen cloth as a result of fire, and if yes, if that changes are capable enough to make a serious impact on radiocarbon dating calculations. So, in 1532, a very significant event had happened in a cathedral where Shroud of Turin was kept in a French city, Chambéry. The long-term fire was happening. And the monks did all they can to protect the shroud by a very simple way, to pour water on a silver reliquary where the shroud has been kept for a while during this time. From the historical records, we know how long was this fire. We know geometry of this box reliquary, which gave us enough ideas to calculate concentration of combustion gases, carbon oxide and monoxide in it. We know temperature too, because the Shroud of Turin has been damaged by melted silver. And Allen and Heller, American scientists, back in 1978, estimated a dramatically increased content of silver in certain areas of the shroud damaged by the fire. So we know temperature of melting of silver, which means we know temperature of incubation. Plus, the silver is a very well-known chemical catalyzer, which is accelerator of all possible chemical reactions. And after all, linen cloth itself contains of cellulose. All linen textiles contains of at least 95 or more % of cellulose. And cellulose is a very well-known long polymer molecule. And chemical structure of this molecule is that this this molecule is very capable to participate in almost possible kinds of chemical reactions. So what we did, we gave historical description of this fire to two independent teams of fire defense experts in France and Russia, with a request for suggestions. What exactly conditions, physical chemical conditions of the fire should we remain constant in our experiments in the lab to imitate, to simulate that particular historical fire? And they both gave us very similar, almost identical recommendations. Then we have obtained a very special sample of linen cloth, which has been given to us through Mario Moroni by Israel antiquity authorities from Israel. This cloth has been excavated in En Gedi site, Israel, and dated historically to early Roman period, which is about 2,000 years before Christ. And morphologically, microscopically, the method of weaving of this cloth very similar to the Shroud of Turin. And of course we had a lot of modern, up-to-date, manufactured linen stuff too. We incubated this stuff in our special conditions, computerized chamber, computerized compartment with a constant temperature, combustion gases, water, silver concentration for a certain time. And before and after this experiment, of course after very extensive washing of linen to remove all possible mechanical contaminations, we have studied the chemical structure and isotopic content in the cloth. So far, is it understandable for you or not? Any questions?
Maybe the linen actually comes from flax, right?
Yes.
That's the plant.
Yes.
Just as a...
Yes. Why a radiocarbon method is capable to date anything? Because radiocarbon is a clock. Okay? That is a number of radiocarbon atoms, and that is time. And the law of decay is exponential or logarithmic. Okay? So, let's say this is 100 atoms, and this is 50 atoms. The time during which a 50% of given amount of atoms will disappear or decay, called half-life period. And for radiocarbon, it's equal to 5,740 years. That law does not depend on pressure, concentration, or temperature, which is good. Now, if you have any object which comes from living organism, like from flax, and if you would be able to measure a content of radiocarbon atoms in it, like here for example, you can extrapolate that measurement to a scale of time into the past, so you will know the age of this relic. Living flax, like all living creatures, absorbs carbon-14 from atmosphere with a carbon dioxide gas. And carbon-14 comes to carbon dioxide from nitrogen-15 as a nuclear reaction. But as soon as the organism died, the assimilation process stopped, and only decay will remain. And that's why it's possible to use it for dating. But of course it's more or less a rough method anyway. Now let's go to our stuff. Well, okay, could you give me a remote control of that or what? Okay. Now, okay.
That's it.
All right.
You flip the switch in the back as well. All the way to the top. There we go.
No, no, no.
There you go.
Okay. Now let me to entertain you. First of all, and I would like to make it perfectly clear, I do not have any problem to being wrong. And I would never claim that a theory we came with is 100% true. And as you can see from my previous explanations, we had no chance even to touch the shroud itself. We're just playing with some other stuff to re-evaluate the dating of the Shroud of Turin. So those conclusions we had about 3 years ago, for example, now seems to us old and they need to be rethinked. So science is a developing knowledge, and that's why I would never say that this is a final step in our search of truth. Okay, this is just a main building of Moscow State University, which is the largest university in Europe, 67,000 students. That particular building has been erected in the 50s under Stalin government, and this is a very huge, green and beautiful campus. And I graduated from this school. This is the main entrance into the university, and this monument is a statue for founder of the school, academician Michael Lomonosov, who founded that university 350 years ago, roughly, which is not very old by European standards. That is the main entrance to the school, just to give you some imagination about it. Okay, this is this person, not very, can you take care of focus, please? I think it's not very clear. No.
Yes.
Okay.
That's pretty good.
Okay. Okay, this is Dr. Ivanov. He defended his. This picture has been taken 2 years ago, or 2.5 years ago. Currently, he has a PhD in nuclear physics. On that time, he was on the way to this. That's me, my secretary, and this is Monsieur Bertot, if you remember him from Rome, Father.
Yes.
This is a person who gave us the first grant for shroud research, and that is his second or third visit to our lab. Excuse me. And this is historical moment. We're saying this is, I would say, it's historical. To me, it's historical. We signing a paper, an agreement for a grant for 1 year long research program in Moscow. You can see snow from the window. It's a beautiful Russian winter. He came from warm Paris, being absolutely undressed, and it's my wife loaned him my coat, and if you can see the difference between me and him, you understand what kind of problem that he has. Alright. Did he have? Okay, and that is a scheme, a general scheme of experiment. I already explained you in non-technical terms. Just very, very briefly, I would pay your attention to that particular stuff. And by the way, if somebody of you is chemist or physicist, and if you would have any technical questions, you could ask them after I will finish. But now I'm trying to be non-technical in my explanations, to be understandable for a lay person. So, we took a textile, no matter what, old or in some cases old, in some cases modern, then we cleaned this textile very, very extensively. Those 3 labs in 80s, they has a perfect procedure of washing of textile, including acids, alkali, detergents, organic solvents, heating, and that particular method is absolutely enough to remove all possible mechanical contaminants from the surface of the fibers. And that's why, in particular, I disagree with some of my colleagues, like Dr. Kousnetsov, for example, who trying to prove a mechanical coating of the fibers on the shroud. I know perfectly that the method of washing of the shroud, which has been employed in 80s and which has been employed in our work, is absolutely enough to remove everything which is not chemical bound to the cloth. All mechanical contaminants should be removed. After incubation in our fire compartment, again we have washing extensively of the fibers, then we isolated fibers, then we analyzed chemical structure somehow, this method called capillary electrophoresis in mass spectrometry. And of course too, we analyzed radiocarbon dating by sending all those samples to radiocarbon facility in Protvino, Russia. And now, the next slide. Okay, I'm sorry. Oh, this. Okay. Even before dating, we analyzed infrared light reflected from the surface of linen before and after fire simulation. Control for solid line means intact linen without or before fire. And punctuated line means experiment, in other words, after fire. We have great difference. And all chemists understand the difference. This is a reaction called carboxylation. This is a chemical introducing chemical incorporation, not mechanical, chemical incorporation of extra carbon from atmosphere as a portion of carboxy group into the cellulose. That peak stands for carbon dioxide, and that difference stands for dehydration for the removal of water from the textile structure. This is a rough but good enough illustration, and further illustration is better. I mean, not so rough and more precise. Okay, that is a compartment we have employed for reflectance light spectroscopy for linen. That is the lasers. I will wait. Perhaps it's for me. Okay, this is lasers. Those huge lasers, this long stuff, were a source of light, which we put into this cloth with a further analysis of reflecting light. And this is a power supply for these lasers. Well, it's just for curiosity, maybe you'll have any questions about it. Alright, and that's what we have. Okay, this is the temperature, and this both vertical axis, and just two different parameters indicating to the level of radiocarbon content in the cloth. This is a point of start, normal temperature, or room temperature. And this is 500 centigrade, about zero. So what you can see, this is a 20% enrichment, increase of carbon-14 in the cloth, and then slight decrease. And until now, we were absolutely lost, honestly saying, in our explanation of that mechanism. And we're still uncertain that we do have the right knowledge about mechanism. So the mechanism of the enrichment of the cloth by carbon-14 as a result of fire is the subject of further extensive studies too. We didn't finish it yet. But what we know exactly and for sure is there is an enrichment, no matter why. We don't know why exactly so far. We know more or less. Well, we have, our explanation obviously is a part of a problem, but not all of it. So what I'd like to emphasize, we have a lot of stuff to do in the future to explain it clearly. But even now, before we'll finish this work, we have confidence to say that picture is reproducible, and this is true picture. In the University of North Texas in Denton, our colleagues repeated it. And the University of Arizona, our colleagues, did not repeat it. But they sent us a description of experiment, and we sent them back with our suggestion because they actually did not reproduce our conditions. But that's another thing. So, this simple stuff is enough to explain 400 or 500 years shift. The fire alone is capable to explain that stuff, which is not enough to date the shroud to the Jesus time. But on the other hand, this is not an end of my presentation as well, right? So this is incubation time with the fixed 200 centigrade degrees temperature. Again, we have an increase. Now, sometimes people ask why we didn't extend that time or temperature far enough to find an equilibrium. We could do that easily if we would have enough museum textiles. We were limited dramatically by amount of very valuable cloth from museums. And our method required a certain amount of textile. If we would have a kilogram or a couple pounds of this textile, we could play with the conditions a lot. But we were very limited by amount of this cloth. We were given just by a couple grams of it. And that's why we were unable to produce as many measurements as we can if we would have a lot of this material. Because of this, that picture looks like incomplete. Now, we have a friend in France, and Father Brinkman should know her. The lady with a very long aristocratic name, Marie Claire van Oosterbeek-Gastouche. And he is a scientist. He used to serve as a scientist at the Belgium Royal Museum for African Ethnography and Art in Liège, Belgium. And she is a very active member of French group CIELT. And as I said, CIELT was the first sponsor of our program. And the second sponsor, I would like to say, was John Jackson Center in Colorado Springs, Colorado. And the third sponsor is ourselves. So now we're working on ourselves. So And that lady gave us a piece of modern linen from the supermarket, which has been burned completely. It was a great fire in the middle of Liège in Belgium. And a huge supermarket was burned out with a fire, like a sort of catastrophe. Some people died, and a very, very well-known event. Newspapers, magazines, radio, and TV told about that a lot. So some stuff from that supermarket were given to this lady, and she gave it us. And this is modern, up-to-date linen after the fire. We washed this linen, and we sent it to a radiocarbons facility in Russia after our measurements. And at the same time, this lady did the same, sending to some European radiocarbon facilities. And you know what? Both radiocarbon labs refused to date it. Why? Because the date was in future, like in Star Trek. I'm not kidding. Because this is up-to-date, modern level of carbon-14, and this is more than modern, which means the future. It's okay if you will put old textile into the fire, so it's more or less younger than it is, but still old. If you will make a modern one, you will have something like this. And it's interesting to note that those labs told that obviously artificially enriched cloth, perhaps by nuclear reactor. But we didn't put it into the reactor, we put it into the fire. It's very difficult to explain it. And John Jackson, a good friend of mine, who is our partner in our studies, professor of physics at the U.S. Air Force Academy in Colorado Springs, Colorado. And by the way, John Jackson was a person who was a leader of a team of American scientists who investigated the Shroud of Turin in 1978. They employed almost all possible methods, physical and chemical methods of their time, except a radiocarbon one. So John Jackson created a very special theory, a huge mathematical stuff in it. I can't explain it in very brief or simple terms. But what he did, he explained that something by a phenomenon which looks like a superficial replacement of carbon of 12 and 13 in the cloth by carbon 14 as a result of kinetic isotopic reactions which happen in reality at the elevated temperatures. And this decrease, for example, could be nicely explained by the theory as a result of saturation of a surface of superficial molecular layer of the fiber by that isotopes. So there is no more room to attack. Something like this. But this is a theory, Jackson's theory, and we have in mind to prove it or disprove it by experiment in next year. And for that particular reason, Dr. Jackson will come to Russia, and already he spent about 10 days in our Moscow laboratory this February. So we are very optimistic about our cooperation for future. Okay. Forgive me for technical something, but what is interesting is, as a result of fire, those is a structure of glucose. And as you probably know, cellulose contains of glucoses. Cellulose is a basis or matrix of linen textile. And cellulose in chemical terms is just a chain of hundreds and thousands of individual glucose molecules. Long chain of glucoses, nothing else. So after the fire, we still have glucoses, but plus carboxyglucoses. And look at this carbon. That structure has 6, 1, 2, 3, 4, 5, 6. And this structure has 7, 1, 2, 3, 4, 5, 6, 7 atoms of carbon. And that carbon comes from, or came from atmosphere, from modern atmosphere, from the atmosphere of the fire. And he came chemically, not mechanically, to what? To old carbons of the relic. This is enrichment by carbon, including carbon-14. And the next slide illustrates the chemistry of this process. This is a segment of cellulose. This is fire conditions. Temperature, silver, carbon monoxide, carbon dioxide, and water. And atmosphere, modern carbon of carbon dioxide labeled by star in our skin. You can see it here. In our conditions, 20%, 20, of all individual residues of glucose were carboxylated or were additionally carbonized by this group from atmosphere. As I said before, this is good for no more than 500 years shift. Then, okay, this is a compartment, by the way, we have employed for our fire experiment. This is a door. Behind it we kept constant gases, water, silver, concentration and temperature. And by the way, some people used to try to do something like we did, just by heating, without water and silver. And they didn't succeed too much. But we, not the first group who used to try to prove a fire as a promoter for chemical changes in a shroud. But we are the first group who paid attention to the historical record of this fire, and we understood that we have to use silver, gases, and water too, not only heat, not only temperature. So, and the result you saw. Now, that is an ugly picture, but interesting. I don't know this word in English, this bottle, whatever it is. Tank, yes. With a manometer on it. This is a mixture of combustion gases, carbon oxide and monoxide. We have ordered from the plants following suggestions given to us by fire defense experts. And it's connected to the backside of our compartment for fire. Monsieur Berthaud, me, and my friend Ivanov conducting fire experiment. He is a very curious person. It was very hard to work in the presence of him, but which means a time of manufacturing of linen. No matter how long ago it was, 2,000 years ago or yesterday, the content of radiocarbon in a whole flax and in a whole linen, resulting linen, are equal to each other, the same. It's not true. It's not true because of a phenomenon known relatively recently called biofractionation of isotopes. All living creatures, including plants, has a unique ability to redistribute radiocarbon and other isotopes too, between them and environment, and within their bodies, between their molecules. Thus, for example, in a flax stems, the content of cellulose is no more than 5 or 7% of dry weight. And in this 5 or 7% of dry weight, 65–70% of whole radiocarbon is concentrated, which automatically means that manufacturing of linen, which is chemically just purification of cellulose, will enrich linen by carbon-14 comparable to total homogeneity of flax. Understand? Okay, let's put it in this way. No matter how many calcium you will eat from your food, all calcium will come to your bones, not to your flesh. Right? The same with isotopes. No matter how many radiocarbon they will absorb, I mean the flax, most of the radiocarbon will come to cellulose specifically, which means the concentration of carbon-14 in the flax in total is less than in cellulose and than is linen cloth, which in other words means this is enrichment by carbon-14. Now you follow me? Or not?
Yes.
Mhm.
So we incorporated this correction together with fire, and we came to a conclusion, re-evaluating the data by an international team of about 1700 years before present, which is still not 2000, but our data are not able to prove still exact date of the Shroud of Turin. We have to work hard about it. Further, we have many things in mind to do. And I'm happy to tell you that all our papers, without one exception, either or published or accepted by central, most prestigious American and British science journals. And those papers are available from Father Brinkman. Of course, they are technical. But what I'm trying to say, conclusion is, we are unable now to prove an exact date of the Shroud of Turin. But we have enough confidence to make two conclusions anyway. First, the actual calendar age of the Shroud of Turin is much younger than those values which were openly announced in 1988 by an international team of radiocarbon experts. And two, not exact but minimal age of the Shroud of Turin, according to our calculations, and perhaps we are wrong, who knows, is about 17 years before present. In other words, according to our stuff, the Shroud of Turin is no younger than 1700 years. We have many things in mind to do, and in particular some our work, some aspects of our work, dealing with not only dating of the Shroud of Turin, but also of the conservation of it. No matter what kind of tests should we do in the future with museum relics, not necessarily shroud, to prove the shroud age, we have to protect it. And this relic is a danger, like all objects, so old. The linen itself, the cloth itself, is not in danger, but image is in danger. It's very superficial something, and since we don't know exactly the chemical structure of chromophores and stuff like this, it's very hard to predict how fast this important object will be deteriorated, and what exactly should we do. So the only way to know it, in our understanding, is to analyze chemistry and physics of many different archaeological textiles, and then to summarize, analyze this data with a further effort to produce any important conclusions regarding the shroud preservation. So by now we collected about 21 samples of linen cloth given to our group by different museums in the world, like Israel, Ukraine, Russia, excavated in Egypt, Palestine, Ireland, England, Russia, Greece, Poland, and dated in a wide range of calendar ages between 2000 years before Christ and 500 years before present. Then we analyzed chemistry and physics of all these textiles with a method I already introduced to you very briefly. Excuse me. Okay. That's interesting. Okay, one of my slides has disappeared. It should be flat just here. But anyway, what we did, we took this simple machine. Look at this. This is a compartment for a textile filter. You could take a piece of linen, make it as a filter, put it here, then here, and this is a pump. And this pump absorbs an air from atmosphere with a constant rate, constant speed, like, 100 liters per square inch per an hour. And then you can expose old and modern textiles to it in different ecological areas. And after, you can analyze a chemical structure. And what is interesting is, depending on ecological conditions, which are different in different geographical areas, this procedure promotes different chemical carbonization, modifications, like methylation, acetylation, and others. If you would treat this cloth with antibiotics, you would prevent this process, which means ecological, environmental microorganisms, air bacteria and fungi, for example, are responsible for this process. So that approach, very simple, gave us some ideas about what kind of chemical modifications could be a result of aging of old textiles if those textiles contacted for a long time with environmental microorganisms in this particular geographical area. Knowing this, it's possible to develop a selective method to prevent that modification. For example, some bacteria can do that in the presence of oxygen, some not. And there are some ideas, like to put the Shroud of Turin into the inert atmosphere. If it would be, but on the other hand, there are many microorganisms which capable enough to survive without oxygen even in inert atmosphere, and in that conditions they will activize their modification of cellulose very easily. And that simple approach is active and efficient enough to prove or disprove many hypotheses like this for further conservation procedures. We didn't come to any conclusion about the shroud, of course, yet, but what we did, we developed this technical stuff for further studies, and we think we could employ it for a development of selective and efficient conservation method for the Shroud of Turin too. Now, okay, this is the first, and I hope not last, conference on the Shroud of Turin in Russia, which happened in 1993, soon after Rome Symposium, in a city called Obninsk. This is a Russian Los Alamos, a city which has been created in the 50s with a specific purpose to create Russian nuclear power. It's about 200 miles north to Moscow, a very special city, a huge nuclear research center there. And the club of scientists sponsored that symposium. Monsieur Berthaud, he is an interpreter, and I represent some literature about the Shroud of Turin in French and English language on that conference this week. It was a very interesting event, and I did all I can to reveal it specifically, and now I'm sure that this is the first conference on the Shroud of Turin in Russian soil. So we are proud and happy to be one of organizers of this symposium. It's exactly 15th of December of 1993. 10 days before Christmas. So that's it.
Okay.
Thank you for attention. And well, again, please please understand. Everything I told you now is science, which means I could be wrong. And don't think that I think that this is 100% true. But I think this is true. It's, to me, it's more logical to think that it's true than not. And this is a result of our 3-year work. And thank you again for your attention. If you have any questions, I would be happy to answer if you have the answer.
Doctor, you're saying that you presented this in scientific journals and it's getting attention in scientific circles?
Yes. Well, sometimes I feel myself as a scandalous because of this. But this is attention, yes, I definitely have a lot of attention. I would prefer to have less attention right now. But as for the responses, we're still waiting for them. The first 2 articles have been published very recently. And the rest of them should be released from the press this year, by Christmas. So next year should be a year of most active discussion of our stuff. In April this year, in Anaheim, California, the city of Disneyland, we have presented our papers at the American Chemical Society meeting. It was the first case where we discussed that very actively. And some people like Al Adler, who also was a participant into the shroud studies in 1978, came there. And we had a very productive discussion. But what is bad about it, every time, listen, if I would try to date a jacket of Abraham Lincoln, for example, nobody takes care about it too much. But as long as I started to produce any sort of conclusions about the Shroud of Turin, a lot of emotions came about it. And personally, I would definitely prefer to have much less emotions about the subject, to be objective. And after all, I would never claim that I'm right 100%, because it's normal to be wrong in science from time to time. But on the other hand, we decided to publish our stuff even premature, preliminary, because we consider that very important. And even though we are wrong in something, let's give a chance others to improve it. Our aim is to stimulate thinking, if even we're wrong. And in that case, I think we succeed. No matter we're right or wrong, but we stimulate the discussion. And next week, a week from now, we'll speak about the Shroud at Duke University. We'll have an interesting symposium there in the physics department. And Jackson will come on. Some other people will come too. We'll see.
Maybe I was running out through telephone calls, but did you ever mention about taking something that was definitely proved to be 2,000 years old and submitting it to the test? Okay.
Historically dated, this was from burial site, Engedi, Israel.
Had it been submitted to a C14 test, or?
Yes, and they gave a date with a 200 years error.
And then when you submitted to the fire and everything, then it...
Much younger. They dated this as 1800 and then 700 years before present.
Has the material ever been analyzed for like spore content? Like different spores or...
Spores?
Right.
You mean Max Fry stuff or something like this?
I'm sorry?
Max Fry observations? You mean pollens or what?
Right, pollens.
Well, we didn't investigate anything like this. First of all, we didn't tie the shroud.
Right.
All we did with the models.
Well, has any investigation been done on that? Pollen content of the shroud.
Microscopically, yes, but not
Yes.
chemically.
Okay.
That's one of the problems, is that you can't get these samples, and the shroud has only been in exposition 2 or 3 times each century. So, and they have never really, the first time they gave it to the scientists was, I think, 73, they gave it to some Italian scientists, and then they gave it to the international group in 78.
Well, actually, honestly, I would, let's put it this way. If I would be given a chance to have a shroud sample now, I would prefer to have it 2 years later. I feel we're still immature to do this. We have something to do, and I hope in 2 years we'll do this. We'll improve our sensitivity of our method, accuracy and stuff like this. But on the other hand, those measurements, which has been done in '88, they're perfect. I do not have any problem with the measurements, only with interpretation. And in order to rethink interpretation, we could provide experiments not necessarily with the shroud, to prepare ourselves to meet the shroud. So we are not ready now to do that work, but I hope, I don't know, maybe it's possible or not, it's not my business, but it's too premature to ask for that kind of sample right now for our group.
Could have the ultraviolet rays in 78, could they have hurt the shroud? Because there were some people said that that could be dangerous to the shroud, because it is so delicate.
It could be dangerous for chromophores, for discoloration, but it has nothing to do with isotopic exchange. It cannot, it's impossible to make an impact on a radiocarbon content by ultraviolet, but which is possible to discolorate cloth, to destroy a border between dark and light. But I don't know if it's happened or not, but it's theoretically it's possible. But on the other hand, as far as I know from Jackson, they used to play with that conditions before they came to Turin in terms of power, distance, certain kind of parameters of that wavelength of the slot to make it gentle. But to what extent they succeed, I don't know.
Doctor, when you talk about all the emotion that's involved in this.
Yeah, you better call me Dmitry, okay?
Okay, Dmitry, but wouldn't you be seen by a lot of people as to be kind of disinterested? Because I think in the American understanding, Russia is not considered a very religious country. So
Russia is extremely religious, uncomparable to America.
you know, but that is
Your country is much less, believe me, religious than Russia.
The religion's much more strong.
I spent about 2 years in the United States in the last 7 years, and I know what I'm saying. I can't compare.
But I mean, am I wrong in saying that is our perception of Russia as...
Well, you have simply wrong perception.
Yeah, but I mean, when you give these presentations to Americans, I think it's helpful to the cause, because I don't think their perception is that you're religious and therefore trying to bolster a
Well, I am religious, that's true. Yes, I'm a Christian, I'm a member of Baptist Church, I'm Protestant, which is very unusual in Russia. Most Russians are Orthodox. But I do not mix it. Let me clarify it. My faith doesn't depend on the shroud. If one day somebody, including myself, will prove that this is not authentic, it has nothing to do with it. It's impossible to ruin the faith by any kind of scientific investigation of any kind of church rabbi. We believe in Jesus Christ, not in the shroud. But if this is authentic, it obviously is left for a purpose, and we have to be very careful about it. That's my position. I cannot understand why some people are so concerned about the shroud as a way to keep constant a faith. Faith has nothing to do with anything except of God Himself. Well, I'm not a theologian, I'm sorry for that kind of discussion, but since you asked me a question. But now, believe it or not, in my personal view, In Russia, we have much more religious freedom than we have in the United States. For example, we have Bible studies in public schools, which is impossible in America. Not in all public schools. It depends on principal, on director of school, but not in law. It's one example. I think it's a very good illustration. And some people in America ask me one of the same questions periodically. How is it possible for Christian faith to survive in Russia in spite of that huge persecution? I would say it's not in spite, but due to persecution it survived. Persecutions are very good for church. Persecution means resistance. Resistance means strength. And strength is good. As an individual, as a person, I would prefer to escape from persecution. But as a more or less educated person, I know from history that persecution improves the strength of nation, of state, of church. So.
Does your government sponsor economically the studies along this line?
Not at all.
No?
Of course not.
No.
We got money from France, from the United States, from our own business. And that's not too expensive, by the way. We already have equipment. We already have people who are dedicated to do something. We have to do to find some spare time, and maybe to employ somebody else. And it's much less expensive than in America, at least. Because economical crisis, we have crisis right now in Russia. We have a joke about it, question, what is the exchange rate between dollar, pound, and rubles? You know our answer, no? 1 pound of rubles per $1. So 2,000% inflation 3 years ago, now we have 300% inflation per year, so it's still fast. It's bad for economy, but it's good for scientific studies. Why? Because per $1 US dollar, you have to employ much better scientists to work in Russia than here in America. The cost for work is much less there than here. And temporarily, it's a good basis for do some kind of joint ventures, which we're doing all the time. We can have orders from the West to do something in the East. And we trade the scientific results, charging our Western partners much less than each average American scientist would charge, which is mutually beneficial. But we didn't have any penny from government, and we didn't even think about it. We have a separation of church and state, like you have, and it's impossible even to ask for such a grant from a government.
Well, thank you, Dmitry, for speaking to us.
My pleasure.
Thank you very much.